see Lindelof videos, AP Calculus, approximation of the area of a region. In this question, we're asked to approximate the area between the curve of f of x is equal to x cubed minus x plus 1 and the x-axis on the interval 0 to 2 inclusive using 4 divisions. So we are going to have n is equal to 4. What's important here is that we're being asked to use a left-hand approximation. So this is what I did, just to take a look at this. You don't have to do it this way. Actually, you don't have to do it this way at all. What I did is this. I just realized that if I have left endpoints, what I have is my approximation is going to be b minus a, the distance there, divided by the number of subintervals, times f of x sub 0, the initial value, instead of the first side. That gives you a left side, plus f of x sub 1, f of x sub 2, etc. So let me just set this thing up a little bit. So I'm going to do that. I'm going to have this thing is from 0 to 2. So the upper boundary is 2 minus 0. It says that n is 4. That means that our change of x, or our width, is going to be 1/2. So that's all I'm going to do now is set that up and say, okay, my approximation is 1/2 times f of x sub 0. F of x sub 0 just means initial, and my first one is 0. So I want f of 0 in this case. And then from 0, I'm going to go over to the right by 1. I'm sorry, I'm going to go over to the right one interval, but each interval is only worth 1/2, so I'm going to take f of 1/2, right? Plus another half over, so f of 2/2 plus f of 3/2. And I'm going to summate that, and that's how I'm going to get my endpoint. Now, just to draw this out a little bit for this one thing, because I have had people ask me, can you just leave it this way? I don't think so. I think you have to actually show this out. So you'd actually have to do that. You'd have to say my approximation is equal to 1/2. F of 0 would be 0 cubed minus 0 plus 1, wouldn't it? Plus f of 1/2 is 1/2 cubed plus, what is it, minus 1/2 plus 1. Plus, now I'm on this one, so I have 1 cubed minus 1 plus 1. Then the next one would be, the last one would be the 3/2, so I have, I'm just going to carry it off down here if you don't mind, plus 3/2 squared minus 3/2 plus 1. Remember, I'm going to summate all of this stuff and then multiply it by this 1/2 because that's our width, that's our change. And let me just show you really quickly what that looks like. And what it looks like is this, you guys. Well, let me go back. It's right here. It's right here. I already did it, right? So I set this up. This is the function that we were just talking about. And all I'm saying to you is this. I'm looking at this thing, and I'm saying I'm doing left hand. So this is my first value here, which is f of 0. And then here's my f of 0.5. This is my, right, because this is a left hand. This rectangle right here, this black one right here, is made from this left-hand height. When you go to the next one, I'll make it a different color so you can see it. It's made from this height. This is that left hand right here, and it makes that one. And this left one here makes the next one. So you can see that I am doing left-hand sums, right? Left hand. That is to say, this rectangle right here, this rectangle here, is based on the left-hand endpoint, right? And that gets, this gets us all the way out to 2. All right, so that's how that was done. I actually did the summation of this, and the summation of this came out to be 2. Ooh, I got to be careful, right? So approximately 2.75. The next video I'm going to do is the exact same thing, but I'm going to do the right-hand sum. So thanks for watching. Any questions or comments, please let me know. You can definitely do this. The more you practice it, the better you're going to get. So thanks.